Hey everybody, back with another Polars tutorial. Hope you're all doing real well. Today I'm going to be doing something different. I'm going to be starting a new playlist, a new series on statistical analysis using polars. So maybe getting away from the data manipulation for at least a little while. I'll definitely come back to that as new ideas come to my head. And getting more into the statistical side of things, where we focus less on data manipulation and more on the actual analyses of these data using some of the statistical libraries that the user community that have been built out for polars. So for this example, there's a couple of libraries that have been developed. The two that I found that have been most fleshed out is Polars DS, which stands for Polars Data Science, and so you're going to need that dependency installed if you're going to run a lot of this. And then also Polars OLS, which is ordinary least squares. It stands for ordinary least squares. It's a library specialized for modeling. And so what I'm going to do today is I'm going to show you a feature of Polars DS, and I'm going to show you how to do a two-sample difference of means t-test. And difference of means just means we have two means that come from two different variables, and we want to test whether or not those two means, there's enough evidence as to whether or not those two means are different from one another. So the data I'm going to be using for this example is some college graduate data taken from a survey. And I have a variable called MRDG, which stands for most recent degree, and salary. And so what I'm going to do is I'm going to test if the mean salary is different between folks with a bachelor's degree and folks with folks with a degree that's greater than a bachelor's. So actually, I think I actually need to run this real quick. Hold on. Python t-test. I think I remember coding something wrong. Okay, so we have two means here. We have the bachelor's salary. So the average salary, the mean salary of a bachelor's holder is $86,000, and the mean salary of a graduate degree holder, so in other words, a graduate degree greater than bachelor's, is $107,000. So is there enough evidence here to say that these are statistically significant? That's why we have a t-test. And so this is just the documentation page. There's 4 arguments to do a t-test. There's variable 1, there's variable 2, so the two variables that you need to specify. And all this information is stored within one variable, and we kind of have a grouping variable, so I'll show you how we handle that. Then there's an alternative argument where we specify the type of test we want to do. There's two-sided, there's less, and then there's greater. I may be dating myself. Like, it's been a long time since I've been in college, but I think these are two-tailed, left-tailed, and right-tailed tests. But we'll go over that. And then there's equal var, which just refers to the type of t-test we want to do. I'll just keep it at the default for Welch's t-test throughout this whole thing. Okay, so to get to the code, so how do we do a t-test? And so I guess just to maybe reiterate, the difference of means test, it tests whether there's a difference between two sample means. And a big requirement of this is the Polars DS library, data science library. That's what I'll be using today. So to bring in the Polars DS library, you just say import Polars DS as PDS. That's what I'll be calling it. And another thing I would recommend before you go and do this is to look at the code examples they give. This can really help because it's not immediately apparent how you do this. So this was very helpful for me to see this, to just see how they do it. So to know that this is nested within a select statement, that really helps. So to do this, we just take our input data set. And so I'm doing a two-tailed test here. And so a two-tailed test means that the means are different, but we're not testing whether one mean is greater than or less than the other. It's just to say that there's a difference. So in other words, if this comes up as statistically significant, we can't see that graduate is greater than bachelor's or that bachelor's is less than graduate. We can just say that there's a difference between these. And so to do that, we do nscg.select. And so NSCG is just the acronym for the survey I'm using. It stands for National Survey of College Graduates. And we do .select because we're going to only keep a subset of variables from this. And we do PDS, so Polars Data Science, .ttest_end. And then the 4 arguments here. So the first variable is going to be the salary, but we're going to do it by the most recent degree filtered by bachelor's. And the second variable is going to be the most recent degree filtered by graduate. And so those are the two variables we're going to be generating means for and comparing. And the type of test we specify is in this alternative argument, and so that's where we specify two-sided. And so I remember what my stats teacher taught me in college, two-sided, two-tailed tests oftentimes test a really crummy hypothesis. Oftentimes you want to explicitly know whether or not one is greater than the other. So we'll go ahead and look at a right-tailed test, and so we'll test if the bachelor's salary is less than the graduate salary. Or is that a left-tailed test? Oh gosh, I'm getting turned around here. But in any case, we specify it with less, and so we're testing if bachelor's is less than graduate. And so the way we do that is exactly the same. It's just the alternative argument is a little different. And then a greater than test, where we test if bachelor's salary is greater than the graduate salary, so the flip side. And we do that exactly the same as well, except we specify greater in the alternative argument. So we'll go ahead and so these return a struct, and so we do need to unnest these. I didn't necessarily want to show that on output, just because it's not so important. We just want to look at the results. But we'll go ahead and run these and see how they look. Okay, so here's our output. We have a statistic, and so that's the test statistic that gets generated, and the p-value. And the p-value is the probability of getting this statistic. And so we see it's 0.0, so very small for these ones. And so that's the two-tailed and the less than test. And so we can say here that there's ample evidence to say here that these two means are different from one another. There's ample evidence from this test to suggest that the bachelor's mean is less than the graduate mean. And then there's not enough evidence here to say that the bachelor's mean is greater than the graduate mean. Okay, guys, so that's all there is to it to t-tests in Polars using Polars DS. I actually have had a lot of fun with this package so far, and so I'm looking forward to making some more videos on this topic. So thanks so much for watching, and have a good day.